Today you're going to divide polynomials using long division. So let's go back to the day when we divided numbers using long division. Remember that first number we see, that 672, it's going to go in your house. So we're going to start off with 672 divided by 21. When we do long division with a polynomial, we're going to do the exact same thing. I'm going to put the 6x squared plus 7x plus 2 under the house and the 2x plus 1 on the outside. Okay? So what did we do back in the day? Well, we asked ourselves, okay, 21 goes into 67 how many times? And we said 3. And that 3 placeholder goes over the 7 because we're thinking of 21 into 67. Okay, so it's the same kind of thinking. It's like you're going to cover up the 1 and you're going to say, how many times does 2x go into 6x squared? Well, 6x squared divided by 2x is 3x. And 3x is going to go above the 7x because it has the same placeholder. So after we determined 21 into 67 in our numeric example, what did we do next? Well, we multiplied. We took 3 times 21, which we found to be 63. Okay, so the same thing we're going to do for polynomial division. We're going to take 3x times 2x, which is 6x squared, and 3x times 1, which is 3x. Now, back to our numeric example, what did we do next? Well, we subtracted, or we changed the sign of the 63 and simplified this to be 4, and then we dropped down the 2. Okay, same exact thing we're going to use for polynomials. We're going to change the signs, meaning we're going to distribute a negative and add like terms. So 6x squareds cancel out, and 7x minus 3x is 4x. And we drop down the 2. And we just go through the same process again. So now we're going to say 21 into 42. Well, that's twice. Okay, and 2 times 21 is 42. Now, what did we do with those two 42s? I changed the sign of the second 42, meaning we subtracted, and we get 0, and 32 is our answer. Same exact process over here. We cover up the plus 1, and we say 2x into 2. Okay? So 2x into 2. Or, sorry, no. Okay, and we do get 2, or not 2x into 2, 2x into 4x, sorry. 2x, we're taking this guy into this guy, which is plus 2. Okay, and then we multiply that through. So 4x and then 2. Well, what do we do with that 4x and that 2? We change its sign because we're going to subtract. So our answer is 3x plus 2. Well, what about something like 3,242 divided by 3? Okay, so we know that the 3, 2, 4, 2 goes in the house because we see it first, and 3 goes on the outside. The same thing is true with our polynomial example. So the 4x squared plus 23x minus 16 goes in the house, and that's divided by x plus 5. Okay, so let's go through the similar process. We know 3 goes into 3 one time, and we multiply the 1 with the 3 to get 3. We change the sign, and we get 0, we drop the 2. 3 goes into 2, 0 times. Change the sign of the 0, so we subtract. Drop the 4. 3 goes into 24, 8. 8 times 3 is 24. Change the sign of the second 24, so we subtract. Drop the 2. And then we have another 0. Change the sign of the 0. And we have 2. Oh no. What did we do back in the day if we had a remainder? Well, we wrote it as a mixed number. We said 1080 and 2/3. Okay, so we're going to do something similar. Like if this example had a remainder, this one will probably also have a remainder. Okay, so we're saying in our minds x into 4x squared. Well, that is 4x, right? And we have the placeholder. 4x times x is 4x squared. 4x times 5 is 20x. Now remember, we have to change the signs because we are subtracting, right? We want those 4x squareds to cancel out. 23x minus 20x is 3x, and we drop down the negative 16. And we continue with the same process. X into 3x is positive 3. 3 times x is 3x, and then 3 times 5 is 15. Remember, you have to change the signs of the bottom expression. So the 3x's cancel, and we have negative 21. Okay, so just like 31. Just like we did with our numeric example, our answer is going to be 4x plus 3. But remember, we have a mixed number-ish. So our numerator, negative 31, negative 31 over what we're dividing by, x plus 5, is our answer. And that's it. Let's look at another example. Remember, the first number is going to go into our house. So we're going to start with x cubed minus x squared minus 2x plus 8. And we're going to divide that by x plus 2. So remember, it's like you're going to cover up the 2, and you're going to ask yourself, how many times does x go into x cubed? Well, hopefully you said, oh, that's x squared. So that x squared goes above the x squared in the house. And now we multiply that through. X squared times x is x to the third. X squared times 2 is 2x squared. Now remember, we're subtracting, so we have to change the signs of that bottom expression. Okay, x cubes cancel out, and we have negative 3x squared. Drop down the negative 2x. Okay, so now we start over. X into negative 3x squared is negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times 2 is negative 6x. And just like we did before on that bottom expression, we're going to change the signs because we do end up subtracting. 4x, and then we drop down the 8. Okay, so x into 4x is 4. And we have 4x, and we have 8. We're going to change those bottom signs again, and notice we get 0. So our answer is x squared minus 3x plus 4. I want you to take a minute or two and try the example you try. Hopefully you get a final answer to be x squared minus 5x plus 3. Let's look at another example. So notice in this next one, notice in the thinking bubble, it says if we had something like 103 divided by 4, do we write 13 divided by 4? No, because there is a 0 in the tens place. Okay, so the same kind of thinking is going to go through with a polynomial. Okay, so you have to account for the placeholders for the x squared term and the x term. So we're going to put 0 x's in those placeholders. Okay, so when we do so, we're going to say in our minds x into x cubed. Oh, well, that is, again, x squared. And we're left with x cubed minus x squared. Remember, we're going to change the signs of that bottom expression because we're really subtracting. And we do get x squared. We're going to drop down that 0x. And x into x squared, we know is 1x. And we have x squared minus x. And we're going to change the bottom signs of that expression. Notice that we will have x, and then we'll drop down the negative 1. We know x into x is positive 1. 1 times x is x. 1 times negative 1 is negative 1. And we change those signs and we have no remainder. And there's our answer. Okay, let's look at another one. If we look at this next example, the first polynomial is going to go into the house. So 3x to the 4th minus 4x cubed plus 12x squared. Now notice that there is no x to the first term, so we have to put in a placeholder plus 0x and then plus 5. And we'll have x squared plus 0x plus 1. Okay, and we're just going to follow the same process as before. X squared into 3x to the 4th is 3x squared. So let's see, 3x to the 4th, 0x cubed, and 3x squared. And remember, we're going to change the signs of that bottom expression. And 3x to the 4ths cancel out. We'll have negative 4x cubed. And we'll have 9x squared. Drop down the 0x. And we start the process again. So we say x squared into negative 4x cubed. Okay, well, that is negative 4x. And we continue the process. Distribute negative 4x cubed, 0x squared, and negative 4x. We're going to change the signs of that bottom expression so we can subtract. And notice we have 9x squared plus 4x plus 5. Okay. Oh yeah, we dropped on the 5. And now we're going to start the process all over again. X squared into 9x squared is plus 9. Okay, and we distribute, so we'll have 9x squared, 0x, and 9. Remember, we change the signs of that bottom expression because we're subtracting. And we'll have 4x minus 4. Now this one, we do have a remainder. Here is our final answer. 3x squared minus 4x plus 9 plus, remember, whatever's left over whatever we divided by. So our final answer is 3x squared minus 4x plus 9 plus the fraction 4x minus 4 over x squared plus 1. Take a minute or two and try the example you tried. Hopefully you found x plus 15 plus 147 over x minus 10 to be your answer. And guess what? We are officially ready for some practice. The end.